Hello everyone. Let's take next CPU scheduling algorithm, highest response ratio next. So in this algorithm, we are going to find a new criteria which is called response ratio. And every time whenever a process is scheduled to the CPU, before scheduling to the CPU process, we generally find this response ratio every time. That's why it is response ratio next. And out of these response ratios, the highest response ratio will be considered first, and after that the next highest response ratio will be considered. What I mean to say, whenever you let's say some processes are available in the ready state, then what you need to find out the response ratio for each available process, and after finding the response ratio of each available process, the highest response ratio of a particular process will schedule to the CPU. And then next time when the next process available, then again we will compute this response ratio, and again we will take the highest response ratio of a process and schedule it to the CPU. Okay, so here criteria is response ratio. So I will abbreviate this response ratio as RR. Okay, RR means response ratio, and a response ratio formula is waiting time plus burst time or service time divided by service time. So here W is waiting time of a process, so far how much a process is being waited in the waiting queue. Okay, that is waiting time, W. And S is the service time, or you can call it as a burst time of a process. Got it? Okay. Then next is mode. So here mode is non-preemptive. Whenever you choose the highest response ratio of a particular process, then till its completion we are going to run this process by the CPU. Okay, that is mean by non-preemptive mode. Okay, so better take an example and try to understand what is the main core or concept behind the highest response ratio. So let's take an example. Consider this example. In this example, we have total 5 different processes available, P0 to P4, and their arrival time are 0, 2, 4, 6, 8. As well as their burst time is also given. For P0, the burst time is 3. For process P1, the burst time is 6. For process P2, burst time is 4. Process P3 and P4, the respective burst time is 5 and 2. Okay, so we are going to find out the first, we draw the Gantt chart, and then after we will compute the response ratio, and based on the response ratio we can allocate the process to the CPU. So Gantt chart will be, so at time 0, how many processes are available? Only one process is available, which is P0. So starting at the time of start, whenever you start a particular, let's say, process, then from starting point no need to find the response ratio. But after that, whenever one process which is arrived at 0, which is completed, after that we will going to find out the response ratio. So here process P0 is scheduled to the CPU, okay, at time 0, and how much time it required? It required 3 units of time, and we know that highest response ratio is in non-preemptive mode. So definitely process P0 will complete till its total requirement. So 0 plus 3 is 3. Now process P0 is completed. At time 3, how many processes are available? At time 3, only P1 process is available. P2 process is arrived at time 4. So here also we have only one process left, which is process P1. So we can schedule it to the CPU, and it requires 6 unit of time. So 3 plus 6 is 9. Now at time 9, how many processes are available? All the processes are available, P2, P3 and P4. Now at this time, there are more than one process available in the ready queue. So we have to find the response ratio of these processes. So response ratio of process P2. So I will subscript as 2. RR subscript as 2. So it will be waiting time of a process so far. It will arrive at a time 4, and now the time is 9. So how many times it will wait in the queue? It will wait in the queue exactly 9 minus 4, which is 5, plus service time. What is the service time of P2? Service time of P2 is 4, which is burst time, and divided with by service time. So it is 5 plus 4 divided by 4. 9 by 4. Can you exactly compute this number? 9 by 4 is 4 to 8. Okay. And the dot, then 1 left. So 4 to 8. So 2.2 exact number. Then response ratio of process P3, which is waiting time of process P3 is 9 minus 6. 9 minus 6 is 3, plus their service time or burst time, it is 5, divided by 5. 3 plus 5 is 8. 8 divided by 5. So it is 1.6. 5 6 are 1.6. Yes, 5 6 are 30. Then response ratio of process P4. Response ratio of process P4 is 9 is the actual time, and it arrives at the time 8. So 9 minus 8 will be the waiting time, 1, plus burst time is or service time is 2, divided by 2. So it is 3 by 2. 3 by 2 means 1.5. Out of these 3 response ratios, which response ratio have their highest number? Definitely process P2 response ratio is having highest number. So after P1, the next process gets scheduled is process P2, and P2 requires 4 unit of time. So 9 plus 4 is 13. 9 plus 4 is 13. Okay. Now after completing process P2, we again compute the response ratio of the available process. So here only 2 processes are available, and remaining 3 processes are completed. Process P0, process P1, process P2 are completed. The remaining are process P3 and process P4. So we have to find the response ratio of process P3 as well as the response time of process P4. So now the time is 13 and P3 arrival time is 6. So 13 minus 6 will be the waiting time of process P3. 13 minus 6 is 7. Now their service time is 5. 7 plus 5 divided by 5. So 7 plus 5 is 12. 12 divided by 5. So how much this number is? 5 to the 10 divided by 4. 5 to the 10 plus 5 4 the 20. 2.4. Exact number is 2.4. Next is response ratio of process P4. So what is the waiting time of process P4? 13 minus 8. 13 minus 8 is 5. 5 plus, then burst time is 2 divided by 2. So it is 7 by 2, and the actual number is 2 3 is 6, 3.5. So definitely response ratio of process P4 is highest. So next process chosen will be process P4. And how much time it requires? It requires 2 unit of time. So 13 plus 2 is 15. Okay. Now only process P3 is left. So there is no need to find the response ratio of process P3, because after all it is the last process to get scheduled by the CPU. So we will directly allocate CPU to the process P3. Okay. Now P3 requires 5 unit of time. So 15 plus 5 is 20. P3 is also completed. Now after computing the Gantt chart, next target will be completion time. So completion time is just see the Gantt chart and follow the right hand number of a process. So process P3 is completed at time 20. Process P4 is completed at time 15. Process P2 is completed at time 13. Process P1 is completed at time 9. And process P0 is completed at time 3. After that, we need to find turnaround time. Okay? Got it? Okay. Turnaround time is completion time minus arrival time. 3 minus 0 is 3. 9 minus 2 is 7. 13 minus 4 is 9. 20 minus 6 is 14. 15 minus 8 is 7. Okay? After that, waiting time. Waiting time is turnaround time minus burst time. 3 minus 3 is 0. 7 minus 6 is 1. 9 minus 4 is 5. 14 minus 5 is 9. 7 minus 2 is 5. Okay? If you want to compute the response time, then response time is same as to the waiting time. So in non-preemptive mode, both waiting time as well as response time are same. If you want to compute, then you can compute also. No need to worry about. So here, what is process when process P0 is scheduled first to the CPU? It is scheduled by the time 0. Okay, so 0 minus 0 is 0, and process P1 is 3 minus 2, which is 1. Process P2 is 9 minus 4. So response time is nothing but this left hand number, and left hand number is subtracted with the arrival time. So 9 minus 4 is 5. Then process P4. So here you have to be careful because it is process P4 and it is process P3. Process P4 came first and then after process P3 came. So it is 13 minus 8, not 13 minus 6. 13 minus 8 is 13 minus 8 is process P4. How much it is? It is 5. And then after process P4. Process P3, sorry, P3. 15 minus 6 is 9. So if you compare waiting time and response time, all are equivalent or all are same. So after that, you can also compute average turnaround time or average waiting time. So the average turnaround time will be, just add this column, 3 plus 7 plus 9 plus 14 plus 7 divided by the number of process available. So here 5 processes are available, so I will divide it with by 5. And similarly, average waiting time will be, add this column, 0 plus 1 plus 5 plus 9 plus 5 divided by 5. Okay, you will get the average waiting time. So that's all about highest response ratio. Next, now if we analyze this particular CPU scheduling algorithm, you will find that this scheduling algorithm is not practically possible. Why it is not practically possible? Because it requires burst time of a process well ahead before running the process. So how can you find the burst time of a process before running the process? It is yes, you can predict the burst time with the help of some techniques, but it is not much efficient compared to the other algorithms like round robin or like FCFS algorithms. So that it is practically not possible. And the second thing is, it will favor the shorter job of a process, as well as it is also limiting the waiting time of a process. So it is much more better than HGF scheduling algorithm, which is we have discussed earlier, shortage of first. So HRRN or highest response ratio next is much more better than the HGF scheduling algorithm. Okay, yeah, that's all it. So in the next video we will see the next CPU scheduling algorithm.